Hi and welcome back. In all of the videos in this JOLT, I have used a generic norm. In other words, I left in the middle what norm I was using. So which norms do we typically use? Well, there's usually a choice of three. The first one is the infinity norm. The infinity norm of a vector is simply the maximum of all the absolute values of the elements. And the associated infinity norm of a matrix is defined as the maximum row sum. So I look at every row of the matrix, I take the absolute value of all of its elements, I add them all up, and then I compare row by row to see which row sum is the largest. Now the one norm is a little different. The one norm of a vector is simply the sum of all absolute values of the elements, and the one norm of a matrix, the associated norm, is defined as the maximum column sum. So it's a little bit like this maximum row sum, but now instead of adding all the elements over a row, we add them up over a column. The other norm associated with the two norm of a vector is the so-called two norm of a matrix. And that is defined, like all induced norms, by the max of x not equal to 0 of ax divided by x. In other words, we take any x not equal to 0, we apply a to it, we look at how big a makes ax, and then relative to x that is, and then we take the max of that. Now, you may recall that this is the same as the maximum eigenvalue of the matrix A transpose, and that to the power a half. So these are the most popular norms that we use, the one norm, the infinity norm, or the two norm. And which of these norms is useful really depends on the problem. Sometimes in a problem I like to use the two norm because it actually means something physically. Sometimes to show convergence, for example, I like to use another norm, maybe a one norm or an infinity norm. So it really depends on the physics and it depends on the mathematical properties. So no matter which of these three norms we use, they all satisfy these inequalities. The first one, here for vectors, is known as the triangle inequality. And the same sort of triangle inequality actually holds for the matrices. And this is true for the one norm, the infinity norm, the two norm, in fact for every correctly defined norm. And all norm pairs, so the one norm for vector with the one norm for matrices, or the two norm for vectors with the Frobenius norm, or the two norm with the two norm, they satisfy this relationship. And you will see in this JOLT that a lot of the core videos use these inequalities.